Hey everyone, and welcome. So today we're jumping into SQL, which, is the language we all use to talk to our data. Think of it as the best way to ask really specific questions and get answers from these huge databases. Right, and we're about to let you in on a little secret, something about how it works under the hood that's going to totally change the way you write your queries.
Okay, so this is something that always kind of got me when I was starting out. We write our SQL queries in this one very specific order, but the database, well, it seems to have a mind of its own and actually runs them in a completely different way. What is up with that? That is the question, isn't it? And it's the core mystery we're unraveling today. Seriously, once you get this, it's like a superpower for writing faster, way more efficient code.
To really get that, we've got to start with the basics. Let's look at the three main building blocks you're going to use to ask pretty much any question of your data.
So when you sit down to write a query, this is what it usually looks like, right? You type select to say which columns you want to see, then from to name the table where all the data lives, and finally where to filter down to just the rows you care about. And on the surface, that makes total sense. You're basically just saying, show me this stuff from this place, but only if it meets these conditions.
Okay, let's dig into that a little deeper. The from clause, you got to think of this as your real starting point. It's like walking into a massive library filled with filing cabinets. You can't start looking for a specific sentence on a page until you've found the right book on the right shelf. From is you walking straight to that specific filing cabinet. In this example, the salesdata.transactions one. It's step one, find your data's home. So, once you've got your filing cabinet, the where clause is how you pull out only the folders you actually need. I mean, you're not going to sift through every single transaction ever recorded, are you? No way. You're going to apply a filter. Maybe you only want sales from last week, or just for a certain product. That's what where is for.
And SQL gives you some really powerful tools for building these filters. You can do simple comparisons like equals or greater than. You can search for text patterns using like, find all customer names that start with the letter J. Or you can define a date range with between. And what's really cool is you can stack these conditions together with and or to get incredibly specific.
And then, finally, after you've found your table and filtered down to the right rows, select makes its entrance. From those specific folders you just pulled out, what information do you actually need to see? Is it just the customer's name and how much they spent? Or maybe you need every single detail? That's what select does. It defines what columns show up in your final result. You can pick and choose, or you can just use select star to grab everything.
All right, that was a perfect breakdown of how we as humans write a query. But, and this is a big but, it's not how the database thinks. From an engineering and performance point of view, this is where it all gets really interesting.
Okay, now this is the big reveal. This slide really lays it all out. On the left, that's our order, select from where. But look at the right. That's the logical order of execution. The database engine takes what you wrote and completely reorders it for maximum efficiency. It doesn't care about the order you typed it in, it cares about the fastest way to get the answer. So it always starts with from, then it filters with where, and only at the very, very end does it figure out what to select.
So let's walk through that, because it's so important. The database first looks at your from clause to locate the table, the big filing cabinet. Then, and this is the crucial part, before it even thinks about the columns you want, it applies your where clause to get rid of potentially millions of rows that don't matter. It's only after it's done that massive filtering job that it performs the select on that much, much smaller set of data. And why do we care so much about this reordering? Well, because understanding this is the absolute key to writing queries that are fast and efficient. When you're dealing with huge enterprise-level data sets, the difference between a smart query and a dumb one can literally be the difference between waiting seconds or waiting hours. No joke.
And this pro tip here just nails the point perfectly. Filtering your data as early and as aggressively as you possibly can is everything. The database is designed to be efficient. It wants to reduce the amount of work it has to do. So the more rows you can get rid of with a really well-crafted where clause, the less data it has to carry through to that final select step.
Look, if there's one thing you take away from this today, for the performance side of things, it's gotta be this mantra. Filter first, fetch last. Burn that into your brain. The goal is always to make the pile of data you're working with as small as possible, as early as possible in the process. That mental shift is what really separates a beginner from an expert.
That makes so much more sense now. And understanding what's going on under the hood isn't just for engineers. For any new analyst, this gives you a super powerful and practical framework for thinking about and building better queries right from the get-go.
Exactly. It helps you build a much better mental model,
So instead of just writing your query from top to bottom, start thinking about it in the order it's actually going to run. First, where is my data? What's my from? Second, how can I filter this down as much as possible with my where clause? And third, only at the very end, ask yourself, okay, now what specific columns do I need to select?
And this right here is why all of this is so critical. A query isn't just a one-time thing you run. A high-quality, well-designed query is the bedrock, the foundation for everything that comes after it. Your dashboards, your reports, even your machine learning models. If that foundation is slow, clunky, or unreliable, then everything you build on top of it is going to be just as shaky.
So, this really just leaves us with one final thought. Now that you know how the database actually thinks, you have this amazing framework for translating just about any business question into clean, efficient SQL. The only thing left to figure out is, what question are you going to ask your data first?